In this video, I'm going to discuss the IUPAC nomenclature of organic compounds. So IUPAC nomenclature is a method of naming organic compounds on the basis of rules set by International Union of Pure and Applied Chemistry. So IUPAC, International Union of Pure and Applied Chemistry. It's a union which has set some rules for naming organic compounds. And so first, before we start to understand the rules, we must understand the common groups or classes or families of organic compounds. There are 10 or 11 common classes of organic compounds. They are hydrocarbons, haloalkanes, alcohols, ethers, aldehydes, ketones, carboxylic acids, esters, amines, amides, and nitrites. And these hydrocarbons, again, they are classified into 4 categories: alkanes, alkenes, alkynes, and arenes. So we will see the naming of each of these categories separately. First, we have to see the naming of alkanes, which are the simplest compounds in organic chemistry. They are hydrocarbons made up of only carbon and hydrogen and having only single bonds. So we will start with that. And once we know how to name alkanes according to IUPAC rules, then all the other nomenclature of all the other families or classes of organic compounds are based on that set of names. So IUPAC nomenclature of hydrocarbons, and we will see alkanes first. So we have to know the names of the first 10 alkanes. So alkanes are having only carbon, hydrogen, and single bonds. So the simplest alkane is called methane, having only just one carbon, and its molecular formula is CH4. So the first alkane with just one carbon, it is called methane. So that is the name given here, with one carbon. The second alkane, which is having 2 carbons, is called ethane. The molecular formula is C2H6, and its structural formula, it is like this. The third alkane with 3 carbons is called propane, and its molecular formula is C3H8, and its structural formula is CH3, CH2, CH3. Similar to this, we have to know the names, the basic names of the first 10 alkanes. So the alkane with 4 carbon, it is called butane. With 5 carbon, it is called pentane. With 6 carbon, it is called hexane. With 7 carbon, it's called heptane. With 8 carbon, it is called octane. With 9 carbon, it is called nonane, and with 10 carbons, it is called decane. So all these, starting from butane downwards, they may have isomers also. Now these names, butane, pentane, hexane, heptane, octane, nonane, and decane, deal with the straight chain compound, not the isomers. So the butane, basically it is 1, 2, 3, 4, a chain with 4 carbons in a straight line. And pentane will be 1, 2, 3, 4, 5 with 5 carbons in a straight chain, not its isomers. Its isomers, according to IUPAC, will have different names. So hexane will be a straight chain with 6 carbons, 1, 2, 3, 4, 5, 6. So heptane will have 7, 1, 2, 3, 4, 5, 6, 7. Heptane will have 8, 1, 2, 3, 4, 5, 6, 7, 8. Octane will have 8, nonane will have 9, 4, 5, 6, 7, 8, and 9, and decane will have 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All these are just the straight chain only. So propane has got 3, ethane has got 2, and methane, of course, having just one carbon atom, we cannot draw it in the skeletal structure. Okay, so these are the names of the straight chain isomers, not the branched isomers. Now based on this, we will name all the alkanes. So there are the rules which we have to follow. Let us see the rules first and then we will see some examples. So the rules, basically you have to follow it in this order. First of all, if you have an alkane, identify the longest continuous chain and count the number of carbon atoms in that chain. This will be the parent, and the name of the alkane with the same number of carbons is given to it. So if in your alkane you are having a continuous chain of 6 carbons, you will call it as an hexane, and then the other branches or alkyl groups attached to that chain will be named with its alkyl names. So first identify the longest continuous carbon chain, count the number of carbons in that chain, and that will be the name of that alkane, the parent alkane. Then secondly, we have to find out if there are any branches of alkyl groups on this longest chain. If there are, we have to find which groups they are. So they may be methyl, they may be propyl, ethyl, etc. We have to find out what branches they are or what alkyl groups are making up the branches. Thirdly, we have to number the chain from both ends. Any chain will have 2 ends, so you can number starting from any end, and it is wiser that you number from both ends and find out which numbering gives the lowest possible numbers to the alkyl group branches. If you number from one side, from the left to right, always it may not give the smallest possible numbers. So it is important to find out whether the number from left to right is giving the lower numbers or from right to left is giving the lower numbers. After that only you have to use the numbers with the lowest possible numbers for giving the location of the branches on the parent chain. Then you write alphabetically, you write the names of the alkyl groups which are branches with its location number as a prefix to the parent alkane name. Let us see an example here. Here is a carbon chain with some branches. How can we name this? This is an alkane, we can see clearly because there are only carbons, hydrogens and single bonds. So first step, find the longest chain which has longest continuous carbon chain. So here we have found it to be having 8 carbons, 1, 2, 3, 4, 5, 6, 7, 8. This is the longest chain. Then, so the parent name will be octane. That will be the parent name because the longest continuous chain is having 8 carbons. So parent name will be octane. Now, determine if there are any branches on it. Yes, there are 2 branches on it. One is this one and one is this one. And what are these groups? This branch is a methyl group and this branch is an ethyl group. So at this point you have to understand what you mean by alkyl group. So an alkane from which one hydrogen is lost is called an alkyl group. So in this case, we have methane minus 1 hydrogen which is giving CH3. So this branch is methyl, and this is ethane minus 1 hydrogen, that means CH3CH2, that is it is ethyl. So the 2 branches are methyl and ethyl. Now we have to find the number of the carbon to which these are attached or the location of these 2 branches. For that we have to number the chain from both ends. We have to number it from both ends. It's not enough to number from one end, then you may sometimes make a mistake. So let us first of all number from left to right. Let us first number it from left to right. So 1, 2, 3, 4, 5, 6, 7 and 8. According to this numbering, the position of methyl group is carbon 3 and position of ethyl group is carbon 5. Now let us number from right to left. Let us number it in another color from right to left. So here the numbering will now be 1, 2, 3, 4, 5, 6, 7 and 8. According to the green numbering, that is from right to left, the numbers of the two branches will be 4 and 6. So 3 and 5 are lower than 4 and 6. So the red numbering is the better one. So we choose that number for giving the location of the branches. Therefore, we have 3 methyl and 5 ethyl. 3 methyl and 5 ethyl. Now we can give the name of the alkane by writing the parent name last, that means octane, and then as a prefix you write the name of the two branches in alphabetical order. So according to alphabetical order, E comes before M. Therefore you write ethyl first and methyl second. But the number of the ethyl is 5 and that of methyl is 3. So you have to put the number as 5 ethyl, 3 methyl, octane. So this is the way of naming an alkane hydrocarbon. Now we will see how to name the different types of branching in alkane in the next video. Thank you.